Okay, welcome year 10s to this next installment in our topic, which is lines and linear equations. As you can see, what we're going to be doing is looking at the equation of a linear graph, but we're going to look at that in two different forms. The first form, as you can see, is called the gradient-intercept form, and you might be familiar with this already. However, you might be familiar with the form y equals mx plus c. As you can see, only difference is we've used a b here this time. The other form of a linear equation that we'll look at is called the general form. So I'll get to that in a moment. First of all, this gradient intercept form, the reason it's called that is quite clear once you establish or once you recall that the m pronumeral that we have here represents the gradient. My apologies, this is just being a little bit, there we go. And of course the b, now this could be positive or negative, remember, represents our y-intercept. So because both of these are very clear in the equation, you can actually read off the gradient and the y-intercept when your equation is in this form. So when it says y equals, and you've got a coefficient with your x term here, and you've got what we call a constant term, just a number on its own, positive or negative, that is your gradient intercept form. Now, it is a really useful form. Like I said, you can read off the gradient and you can read off the y-intercept, which means that in terms of sketching, you've already got one coordinate, really, because you can read off the y-intercept and you know that the line passes through that point. You can then obviously get your second coordinate by substitution, and that's something we're going to look at in the sketching video. So the gradient intercept form, very important that we don't mix these two up. One thing about the gradient is it will always be the coefficient of the x. So at the moment it's written first in the equation, but don't just assume that if it's written first that it is the gradient. You want to make sure that it is actually the coefficient of the x. So it's the number that's being multiplied by the x variable. So I just wanted to make that point. What I'll do now is show you a couple of examples of what we could do, what we could be asked with the gradient intercept form. And I'll just find it, sorry. And I want number 50. Oops. My apologies about that. That was a bit slow. Okay, so here we have gradient of a line is -4 and the y-intercept is 3. What is the equation of this line? Okay, well, haven't been asked what form it needs to go in, so I'm just going to use the gradient intercept form because it's nice and straightforward. If the gradient's -4, I can say that m is -4, and if the y-intercept is 3, I can say that b is 3. Therefore, my rule, which is y equals mx plus b, will look like this. Y equals gradient -4 x plus 3. And there's my equation. Alternatively, you might be given an equation like this and then asked just to state the gradient. So here I can see y equals mx plus b, but as you can see, my intercept is actually negative here. So the gradient m is -2, and the intercept, y-intercept b, is -5. I'll just clearly state what I mean by m equals. Obviously I'm referring to the gradient, and by b I'm referring to the y-intercept. Okay, now that's the general form, so we're going to make more use of this shortly, so we're not finished with it just yet. Just head to this section now. I want to talk about equations of horizontal lines. The reason is if we know that y equals, and this is our general form, y equals mx plus b, horizontal lines we know are pretty special because as we discussed in one of our previous lessons, the gradient will always be 0 for horizontal lines. So what this means in terms of our general form of the equation is if you have a m value here of 0, you're actually not going to have that x term because the x term is always going to multiply by 0. So effectively it's cancelled out. It means that when we have horizontal lines, they're going to be in this form, y equals b. So y equals whatever the y-intercept is. So I wanted to give you a few examples of that. Just say I had, I don't know, y equals down here -1. So I've got a horizontal line passing through that point. Try and line it up nicely. There we go. That horizontal line there is going to have the rule, have a look at the intercept, it's -1. It's going to have the rule y equals -1. We're actually not going to have an x variable in there. I know that's sort of weird to come across, but if you think about it, the x values along here, the y values I should say, they're always going to be -1 no matter what. So if I take this value here as an example, that's going to say, I just made it up, is that x value of 5, and the y value would be -1. Over here, x value, say, of -7, y value, -1. It's always going to be the same value for your y. Alternatively, of course, if I had, say, a +1, I don't know, something like that, +5, I could put in horizontal line across there, and of course my rule would be y equals 5. Don't want a line anymore. Here we go, y equals 5. You could even get something like, I'll try and make it clear, you can get a line sitting right on the x-axis. There it is, I've just drawn it straight over the top there. That's actually passing through the origin. So that one will be y equals 0. Of course, because we've talked about horizontal lines, I also want to touch on vertical lines. So if I go back to here we go. So equations of vertical lines. You remember that when we talked about the gradient, m, that'll be undefined for equations of vertical lines. So we're not going to draw these, we're not going to write these equations in the standard, in the form that I was talking about before, the gradient-intercept form, because of course it doesn't have that gradient, and unless it's sitting on the y-axis, unless the vertical line is actually sitting right on top of that y-axis, it's also not going to have a y-intercept. So that, of course, means that, or what are we left with, really, in terms of our equation? Just a note, I haven't drawn it on all of my axes here, but of course, these are all y, x, etc. I'll just make that point before I continue. Just say we had a vertical line going through 3, just here. I'll draw it in. It's actually going to cover my label, that's okay. This rule, if we think about it, well, the x value is always going to be 3 for this line. So what we can say is this vertical line has the rule x equals 3. So you see, it's just the opposite of our horizontal lines. They've always got the rule y equals. Vertical lines always have the rule x equals. So just do a couple more. -2, for example. we'll have a vertical line through there. I'll just try and lift it off so I don't break it. And x equals, of course, -2. And just like my example before, technically, we can get a line that sits directly on top of that y-axis, which is vertical. And of course, that would mean that we have a line x equals 0. So one thing that I sometimes mention, just if you are worried about getting these mixed up, there is a little thing that you can memorize, I guess, which looks like this, hoi vux. And what that actually means, if you manage to memorize this, means that stands for horizontal lines, and the O there is actually a 0. It's actually meant to stand for a 0. Horizontal lines have a 0 gradient, and the Y means it's got the rule Y equals. Vertical lines, of course, is what the V means. The U, you've probably guessed, means undefined gradient. And, of course, the last bit, the X, I'll just say undefined M because I'm running out of space, will have the rule X equals. So that's one way that you can sort of recall these particular rules in terms of vertical and horizontal lines. Okay, what I mentioned at the start of the video was that there's a couple of different forms that we can write an equation in. So one of the ones we've looked at already, if I go back to it, where is it? Oh no, back again, maybe I've closed it. There it is. The kind of form we were talking about before was the gradient-intercept form. So that's where you can clearly read the gradient and the intercept from the rule. So it'll say y equals. The second form we're going to look at is called the general form. And I'll show you an example of what that will look like. I'm going to have to go back to this page over here. There it is, I want number 19. Okay, so, no, that's not what I wanted number 18. Sorry about this. I'll get to those examples in a moment. So this is what the general form will look like. So have a look at the difference. Compare this one to the one that we used before. The general form of a linear equation, you'll see some things that are in common. Of course, the x and the y variables will be present, but we actually have it equal to 0, so that's a little bit different. And we've got here a's, b's, and c's. Of course, we had an m before, m for the gradient. We did have a b before, which represented the y-intercept. But in these cases, with the general form, we can't, we're not going to be able to read, or depending on the equation, generally you're not going to be able to read the gradient and the y-intercept directly from the equation. So these here, these are just going to be your numbers. So we'll have a value. Generally, a and b won't both equal 0. I probably could have written that a little bit better, but a and b won't both equal to 0 here, because then of course we're just going to have a number equal 0, which doesn't make sense at all. So if one of these could be 0, but not both of them. Now, importantly, the equation of every single line can be written in this form. So even if you have one that's written in the gradient-intercept form, you can actually convert it to the general form, which is something that we're going to be doing. You can also then, of course, transfer this general form into the gradient-intercept form, which is another thing that I'm going to show you before the end of this video. So, going back to where I was before, which is this here. I want to write these, which you'll see are in gradient-intercept form, in the general form. So just a reminder, the general form, just written up the top here, ax plus by plus c equals 0. So I want to make this look like that up there. Okay, so how do we do that? Well, we'll start off with an easier one here. My first step, as you can see, is I've got a 5 denominator over here, and I want to get rid of that. To do that, what I do is I multiply the entire equation, both sides, so effectively every term gets multiplied by 5. This will look like I have multiplied every term. We'll just fix that so it looks more like an x. Multiplied the entire equation, therefore every term, by 5. The reason I did that is because now, as you can see, that denominator of 5 is now cancels out. So I've got 5y equals x minus 20. The next thing I'm going to do is I want this equation to equal 0. So what I can do is first see how I've got positive x on this side. I'm going to subtract x from both sides. And I'm going to add 20 to both sides. And you'll see I've got that equal now to 0. The only thing I'll do is I might just rearrange this or swap these around just so that it is in that exact form that I've written above. So the first term you'll see is the x term, which is negative x. Then I've got my y term, so plus 5y. Then I've got the c term, which is the 20, the constant term, the number on its own, and that is equal to 0. And now that is in general form. I can do the same thing with this equation here. This one is going to be a little bit more challenging because you see I've got two different denominators. It's not as easy as that one over there. I am going to do a little trick that we have used before. The best way to eliminate two different denominators, like I've got here, is to multiply by the lowest common multiple of those. So the lowest common multiple of 7 and 6 would be 42. So what I'm going to do is I'm going to multiply every single term by 42. Now, I'm going to leave it as 42 by 4 over 4x over 7, just because there's no point in me multiplying the 42 by the 4, because I can actually cancel this out anyway. So I've multiplied everything by 42. And the reason I'm going to do that is I can do some nice cancelling now. So 42y. So 42 by 4 on 7. 42 on 7 is 6. So 6 by 4. So effectively what I've done is this. Let's try and make that a little bit clearer. 6 by 4, 24. Plus 42 on 6 is 7. Now that is a lot nicer. We've removed those fractions, or we've cancelled them out. 42y. I'm now going to subtract the 24x from both sides. So that's equal to 7. And finally, I'm going to subtract 7 from both sides so that this is equal to 0. So subtract the 7. Now I've got that equal to 0. Now what I'll do to finish it off, like I did before, just because it's conventional, if I write the x term first, that's negative 24x. It's not absolutely necessary because it is still the same thing, but I just wanted to do that so that you can clearly see that I've written it in that form, the form that's written in purple up here. Ax, in this case a is negative 24, plus by, b is 42, and c here is negative 7. So that is our general form, and that is a conversion from the gradient-intercept form into the general form. The last thing I want to show you is working backwards from there. So working from something in the general form and getting it into a gradient intercept form. Now, of course, I'll need to just open that up. This is the last one that I'll do in this video. Here it is here. So as you can see, I've got 2 in the gradient intercept form. I want to rearrange this so it is, I've got it in the general form. I want it in this form here, y equals mx plus b. I actually find these a little bit easier than the ones that we just did. Reason being, we're basically just solving for y, or making y the subject, in other words. So first step, as you can see for this one here, I need to isolate this 3y. I need to get it on its own on one side of the equation. So you can do this in one step if you want. I'll do it in 2 here. 3y minus 2x, my first step, I've subtracted 12 from both sides. Next step is I'm going to add the 2x to both sides. So 3y equals, I'm just going to now I've put a negative there when I wanted, I've put a positive when I wanted a negative, so I'll just fix that up. And finally, I'm going to divide both sides by 3. You can do it all over the one denominator, but the reason I'm doing it in 2 is the 2 on 3 is going to stay as 2 on 3. Can't cancel out any further. The 12 on 3 will simplify to 4. So of course you might have written it just 2x minus 12 all over 3, and then of course you can simplify from there. All right, I've now got that in the gradient intercept form. The gradient is 2 over 3, the y-intercept is negative 4. I'll do one more of these. As you can see, they're very, very similar. First step is, you'll see I've got 3x written first this time. So what I'm going to do is I'm going to subtract 3x from both sides. So it's positive here, so I need to subtract it. Oh, actually, I have a better idea. Just looking at it. If I've got everything's on this side and I want the y to be on its own, it's actually easier to add the 5y to both sides. Like so. We'll be able to do it in a lot less steps because we're basically just working with getting this onto that side effectively. So we've added the 5y to both sides. We're left with 3x plus 15 equals 5y. And of course, now we divide both sides by 5. Oops, I want my white back. There we go. So 3x on 5 plus 15 on 5. Again, you can do it all over 5 and then simplify. It won't matter. And finally, I'll simplify from here. 3x on 5 will stay like that. 15 on 5 is 3. So there's my gradient intercept form from the general form. In the next video, we are going to work with these further because we are actually going to sketch. But I will save that for a second video because it is quite a different skill.